Hello everyone, welcome to CodeGuide, and today we'll discuss the topic Model Context Protocol, that is the MCP. And in this live presentation, we'll discuss its definition, why it is needed, where it is used, the core idea behind it, the components of MCP, the comparison between the traditional versus MCP, the MCP in agent workflows, how MCP supports tool usage, MCP and long context management, and also the benefits and challenges. So let's start with the definition. Now, it is the Model Context Protocol, that is the MCP, which is a framework or a standard for defining how context is structured, parsed, and interpreted in GenAI systems, especially in multi-agent and tool-using environment. We can also define it as a standardized way to manage context for AI models like ChatGPT or Cloudy. It defines how to structure, pass, and update information between an AI models and the outside world, like tools, memory, or multi-turn agents. Now, you can also think MCP as a shared language between the LLMs and external tools to handle input, tools, memory, and output effectively. MCP helps LLMs retain memory, adapt to tasks, and interact with tools or environment more effectively. Whenever we LLM generally tend not to remember all the conversation, past conversation. If the conversational history is too long, it forgets most of the time. So this task is retained by using the MCP, which is the retained memory, and it adapts to tasks whichever it is assigned. And in case of the tool, it can interact and it can interact more environment friendly. So that is the use of MCP. Moving on, now why it is needed? LLM need structure for managing long and complex instructions and also maintaining context over multiple turns, coordinating between agents and tools, ensuring consistency and traceability in generation. Now, whenever we consider the LLM or the large language model, they struggle with long conversations. They lose track of memory or tool actions, and it needs help with multi-step logic. So, MCP solves this by keeping track of the state and making tool usage easier and safer. So, and also it manages long and evolving conversations. So, in this context, MCP is generally needed. Now, without MCP, the prompt becomes more chaotic and difficult to scale. So, this is the advantage of MCP. Now, where it is used. Now, common use cases are multi-agent orchestration, that is the QA and line graph. We have seen these two parts. Next is the tool augmented LLM with memories, databases, and APIs. And we also have the context switching between the task, agent state tracking in RAG pipeline. So, multiple use cases are present here. Now, in case of the agentic framework, line graph, QA, or multiple agent framework, we can use the MCP in multi-turn chat tool using agent. This is the tool augmented LLM, that is the tool using agent. We have also the RAG pipeline, that is the retriever augmented generation. Now, anywhere where context tracking and decision memory are needed, MCP is used. Now, MCP is emerging as a standard protocol for scalable LLM applications. Whenever there are complex tasks involved and multiple agents or multiple tools are involved here, and to keep the track of the agents and the tools and the context provided by them, MCP is generally used to scale LLM applications. Now, the core idea behind MCP defines a structured format for context that includes user input, system tools or agent goals, and previous steps or memory and constraints or roles. Now, whenever we can also say that the core idea behind MCP is like treat context like structured data. Wherever context is involved, it treats it like structured data. It can track it, it can update it, and then share it consistently. Now, MCP defines what the AI knows. Now, AI can basically know the input, memory, tools used, what the AI can do, like the tool options or output, and how the AI thinking flows from step to step. You can also think of it like a contract between the prompt and the model. This is the core idea behind the MCP. Now we'll see the different components of MCP. First of all, we have the system and we have the role and behavior definition for the system. We have the instructions, that is the user goal. We have the history, prior messages or tool calls, whatever the tools have given the output, and the prior messages which were feeded earlier is done by the component history. The tools use available APIs or functions, the state agent specific info, and we have also the scratch pad, that is the intermediate step which were taken during the LLM functioning. Now it helps models behave more consistently and predictably. So this is different components we see in MCP context. Now the input basically can be also the component where the user message or current task is involved. Whenever the user message is passed, uh, that can be considered as an input. Then we have the state. All known input so far is known as the state, and the memory, history, tools, variables used by the LLM powered application. We have the tools called, so structured info about tool usage or needed action. We have the tool output, that is the result returned from those tools, and also the next steps, that what should the agent do next. Another tool of final output. Everything is structured as a dictionaries or JSON, so agents and model can work with it easily. Whenever we are considering the MCP context, it is structured in a dictionary format or JSON format, and because of it, the agents and models can work with it easily. These are the core components of the related to the MCP context. Now we'll see the comparison between the traditional versus MCP prompting. First of all, if we consider the structure, the traditional prompting structure is loose as compared to the free text, or we can say it is loose or free text, while as the MCP prompting is JSON-like or structured one in the dictionary format. In case of memory handling, it is manual via prompt stacking, but in case of the MCP prompting, it is built in via history or scratchpad. The tool awareness in the traditional prompting is minimal. Whatever the tool output or the input which has been passed towards, in case of the traditional prompting, it is not maintained or recorded, but in case of the MCP prompting, it is explicit with tool schema. In case of scalability, traditional prompting is poor, well as the MCP prompting is higher. MCP is more organized, repeatable, and interpretable. These are the advantages of the MCP over the traditional prompting. Moving on, now the MCP in agent workflows. In multi-agent system, in each agent uses MCP to know its goal, memory, and next step. Agent hand off output to others using a shared context, and it helps coordinate long, complex tasks like research or planning. In agent-based systems like the line graph or QA, MCP helps by storing intermediate thought. It can do the logging actions and decisions. It can manage the tool usage across different steps, and it ensure the long-running consistency. So agents can remember what tools they use and what they got and what they are planning next. MCP can be also defined as the foundational to framework like QA and LangGraph. So this is about the MCP in agent workflows. Now, how MCP supports tool usage. When an LLM needs to decide which tool to call, or provide the right input argument, or use the result feedback. So in all these cases, MCP supports the tool usage. In general, we have multiple tools assigned towards an LLM. While using the MCP, it can decide which tool to call, and it provides the right input argument, and it also uses the result feedback. Now, MCP helps structure like tool schemas, input output format, and usage history. It enables reliable function calling and tool chaining. In case of MCP and long context management, uh, one of the most important thing is that LLMs can't remember everything in long text. So LLMs generally struggle with forgetting earlier context, misinterpreting role-based tasks, and juggling memory across tasks. So, what does the MCP does to solve this? It is using the structured, quick, consistent agent state and modular prompt building. So, by using this, we can remove the disadvantages which was previously struggled by the LLM. It reduces hallucination and improves task accuracy. As we have discussed earlier, hallucination is the main issue with the LLMs we are using, and that can be solved using MCP. And also the task accuracy according to the user can be increased. Now, also MCP helps in storing only relevant structured data. Whatever the relevant structured data is available, not the full text, it helps by storing it. And also, it also reuses text between the calls. It passes around summaries, references, or actions instead of repeating. Now, it can also save the token space and boost performance. So, this is the MCP and long context management. Now, benefits of using MCP. MCP provides clarity in complex interaction. It can also do the modularity across multi-step workflows. It is scalable for larger AI systems. It has robustness with tools, memories, and roles. In case of the consistent memory, it keeps track of what happened across each step, and it has smarter tool use. So it tracks tools used and their outcomes. For long-term reasoning, it builds knowledge over time. And for easy debugging, developers can inspect structured state. For a framework compatible, it works with LangGraph, QA, and others. Now, it is especially useful in production grade genetic systems. The challenges and future of MCP. The current limitations are it is still evolving and unofficial. It can increase the prompt size. It needs standardization across tools. Now, complexity, in case of complexity, it adds some structure overhead. So, complexity is always increased here. The model support, it needs model that understand MCP format. So, model support is also very much needed. And for the tool integration part, it requires tool to follow protocol format. In case of the standardization, it is still evolving across different frameworks. Now, in future, while considering the future of the MCP, more models will natively support MCP. Currently, all models don't support MCP. Frameworks like LangGraph, OpenAI agents, and QA will adopt it deeply. Now, tools used will become zero shot and dynamic. These are the future concepts of the MCP, and we can expect integration into open standards for agents, workflows, and LLM API. While considering the summary, MCP is a way to structure and manage context in an LLM system. So wherever the structured data context is involved, and we can manage context in LLM system, MCP will be involved. It is crucial for agents, tools, RAG, and scalable GenAI solutions. So it can enable long conversation and workflows. So it is crucial for such tasks. It provides clarity, modularity, and memory retention. It can track memory and state also. It is a becoming core layer of modern multi-agent AI app. It manages multi-step agent reasoning also. It uses tool more reliably. So generally, if Langston gives LLM tools, MCP gives them a memory and a brain. So these are the questions for you guys. You're building an LLM that writes reports using three steps and two tools. How would MCP help manage this process? So I expect from you guys to work on this problem, and we'll discuss the solution in the next section. Whereas the other question is, what are the risks of using unstructured prompts in a multi-agent or tool using AI? And I also hope that you find out the answer about this question, and we'll discuss these answers in the next section. I hope you guys understood the NCP context, and if you understood, please like and subscribe our channel, and I will see you in the next video. Till then, bye.